Alright, our next problem with optimization is going to look at Scuba Steve. I don't know if any of you know the movie that Scuba Steve was off of, but we're going to do a problem with him anyway. So he decides to open his own diving store. After being open for a while, he figures that he is selling about 150 scuba tanks a week at $225 per tank. He asked his associates to take a survey and discovered that for each $15 rebate he offered to the customer, he could sell 50 more tanks a week. How much of a rebate should Scuba Steve offer his customers to maximize his revenue? What would be the price of a tank with this rebate? So we're wanting to know how many $15 rebates does he need to give in order to maximize his revenue. For each $15 off, he's increasing his revenue because he's selling more tanks. But at a certain point, he's going to offer too little money and not make enough. So we want to maximize his revenue. So the first thing that we want to make sure and do is to come up with an equation that gives us his revenue. So he's selling tanks at a certain price. So his revenue is going to be the number of tanks times the price. Now, we're not just going to multiply 150 scuba tanks times 225. That just tells us what he's making per week right now. So we're talking about some kind of change. So his revenue is going to be the number of tanks times the price per tank. All right, so we want to represent an expression for the number of tanks. So the number of tanks he starts off with is 150. But for each revenue, or for each rebate he gets, he is going to sell 50 more tanks a week. So we're going to add on 50 for each rebate. We don't know how many rebates, so we're going to call that X. So that's the number of tanks that he would sell in any given week. Then the price per tank right now is at $225, but he's going to offer a rebate, which means $15 off. So we're going to subtract 15 for each rebate he gives out. All right, so this is the formula or the equation for Scuba Steve's revenue per tanks. All right. If you want to kind of tell us what X is, that would also be a good idea. So X is the number of $15 rebates. So if he gives two $15 rebates, he's actually getting a $30 rebate. All right, so we want to maximize his revenue. So we want to figure out at what X value will make this equation maximum. So we're going to find the derivative, and we're going to take the derivative with respect to X. You could simplify this now and then take the derivative, or take the derivative and simplify later. It really doesn't matter with this step, so I'm just going to go ahead and dive in and take the derivative. This is a product, so we're going to have to use the product rule. So I'm going to go ahead, I'm going to pause, I'm going to take the derivative and simplify. You go ahead and do that as well. Okay, hopefully you get down to this, 9,000 minus 1,500x. So since we wanted to find maximum, we're going to set this derivative equal to 0 and then solve. So if we solve for x, we're going to subtract 9,000 divided by negative 1,500, so you'll get a positive 90 over 15, which is 6. Okay, so what that means, what that should mean, is that he would offer 6 $15 rebates in order to maximize his revenue. But again, you always want to check. So I'm going to make a sign chart for the rate of change of the revenue at 6. And remember, we don't want to, we're going to stop at 0. We're not looking at 0. So we're going to look at just either side of 6, so 5 and 7. So with the calculator, or actually you don't even need the calculator for this, 9,000 minus 1,500x is pretty easy. The 4, 6, and 5 is going to be a positive value. After 6 and 7 will be a negative value. But always just keep that in mind, always double check that before you conclude. So our final statement here would be that Steve needs to offer 6 $15 rebates in order to maximize his revenue. All right, for sake of time, we're going to go ahead, I'm going to do 2 and example 3 as well. That one was pretty fast, and I don't know why this keeps coming on, so I'm sorry about that. So we're just going to go ahead and go to the second video now. Not the second video, the third problem. Okay, so we're back to Emmanuel the duck. Okay, Emmanuel the duck is kind of strange. He likes to collect random things he finds and make artwork out of them. I know this is silly, but bear with me. One day he found a 96-inch piece of string by the side of the road. He decided to cut it into two pieces and form one into a square and one into a rectangle. All right, with its length 3 times its width. All right, so we've got a square with its dimensions. Those should be squared off. Dimensions that are the same, and then the length 3 times its width for its rectangle. But he wants to make them have the smallest total area. Where should he cut the string? Okay, so with this type of problem, we want to find the smallest total area, so we want to minimize area. So whatever you want to minimize or maximize, you need to find a formula for that. So if I want to find the area formula for this, the formula for the area of this square would be x squared. The formula for the area of the rectangle would be 3w times w, or 3w squared. All right. Now this poses a problem because we have this in terms of x and w. We only want it in terms of one variable. So we need some other formula that relates x to w. So they also tell us that the string is a total length of 96 inches. So that would be the total perimeter. So the perimeter of the square would be 4x, and the perimeter of the rectangle would be 8w. And we know that that equals 96. Okay, so we're going to use this. This is basically now a system of equations. So we want to get one in terms of the other. It really doesn't matter, but I like to kind of think ahead and think what would be the easiest. So if I want to get this perimeter equation in terms of one variable, think about which one would be better to solve for. If you get x by itself, you'll be dividing by 4. If you get w by itself, you'll be dividing by 8. I like to divide by the smaller number because 8 divides by 4 evenly, but 4 divided by 8 becomes a fraction. So I'm going to solve for x. So x will equal 96 minus 8w divided by 4, or what is that? 24 minus 2w? Yes, to make sure. Okay, so that's x in terms of w, and now I'm going to substitute that into my area equation. Now I'm not going to simplify here. I'm going to go ahead, now that I have everything in terms of w, I'm going to take the derivative with respect to w and simplify. Alright, so making sure you use the chain rule here. That's something that a lot of people might leave off. And then simplifying, you should get 14w minus 96. We want to find, what is it, a minimum. So we set this equal to 0. So w is equal to 96 divided by 14, which is, well, we go ahead and put 96 divided by 14. When you put that in your calculator, you get 6.857 inches. All right, we want to check to make sure that that is in fact a minimum. So using the tricks that I taught you with your calculator in problem 1, go ahead and try that again on your own. And when you try that, so make sure pause the video, try it on your own. When you try that, you should get a negative and a positive. Therefore, this is in fact a minimum, or minimizes the area. So the question asked, where should he cut the string? We just found the width of the rectangle, which is not where he should cut the string. So he would want to cut the string at a place where the two perimeters would be split. So if the width is what we have, we would want to find the perimeter of the rectangle. So the perimeter of the rectangle was 8w. So he would want to cut the string at 8 times 6.857, which is 54.857 inches. So again, your final statement would be that Emmanuel would want to cut the string at 54.857 inches in order to minimize the total area of the two pieces.